So this is problem number 20 from the review guide involving our projectiles at angles. Two keys here. We were given that the arrow was fired at 64.5 meters per second at an angle of 32.5 degrees from the horizontal, which means that it's traveling both vertically and horizontally as it moves towards a tree. One of the things that makes the problem a little bit easier, the arrow was fired at the exact same height that it hit the tree at, which makes the problem a whole lot easier in terms of trying to find the time. But let's figure out exactly what we need to do here. So the first key is that we need to break down the motion at an angle into the two axes that we know how to deal with. We know how to deal with the x and y axis. We don't know how to deal with something on a 32.5 degree angle. So we need to find the Vx, the vertical component, or the horizontal component of the velocity, and the Vy, the vertical component of the velocity. So again, because this is our vector, this 64.5, we can break it down into its two parts, and we can see our little triangle here. Hopefully you can tell that the hypotenuse is going to be our actual velocity of the object. The opposite side of our angle is going to be the vertical component, or the Vy, and the adjacent side of our 32.5 degree angle is going to be the Vx. So we can find Vx and Vy by doing V for Vx. Since we're dealing with the adjacent side, that is going to be V times the cosine of the angle, cosine of theta. For Vy, since it is the opposite side, it's going to be V times the sine of theta. Okay. That will give us our two components of the velocity, which will allow us to figure more out about the actual motion of the object. So the nice part is, for projectile motion, gravity doesn't influence the motion of the object. It just keeps traveling horizontally at the same speed the entire time, because gravity works vertically. Nothing's slowing the object down. There's no air resistance. So to find our dx, which is actually what we're looking for overall, all we need to do is do our velocity in the x-axis times the time that the arrow spends in the air. Since we're moving at constant speed, distance becomes very easy. It's just velocity times time. But the key is it's that velocity in the x-axis. If we use the overall velocity, that's not really going to determine how far it goes, because that's also pushing the object up in the air in addition to pushing it horizontally. So the key then becomes finding time in the air for this object. Well, the nice part is, if we start and end at the same height, since in the vertical axis it's the exact same as free fall, okay, the time for this arrow to go up is going to be equal to the time for this arrow to come back down. Okay. So the time in the air is going to be T air. It's either going to be 2 times T up or 2 times T down. So we need to figure out, well, which one of these is going to be easiest to solve for. So let's think about things we know on the way up. Well, we know the final velocity on the way up is 0. Now, there's a key with that. It's 0 meters per second in the y-axis. So we're only dealing with the y-axis, this Vy in this case. Okay, so the final velocity going up at the very top is going to be 0. The object is still moving horizontally. It's still going horizontally at whatever V times the cosine of theta is. It's still moving this way. It's just no longer going up anymore. So we know the final velocity at the peak is 0, just on the y-axis. We also know that g is -10 meters per second squared. It's how fast it's slowing down on the y-axis. Again, only dealing with the y-axis because we're dealing with gravity. We're basically dealing with a free fall situation. The other thing we know is the initial velocity. The initial velocity of this object only vertically. It's all we care about. We don't care about the angle of motion or the horizontal motion. We only care about that vertical motion right here at the very beginning is going to be Vy from the initial portion, the initial vertical component of the actual shot, the actual 64.5 meters per second at 32.5 degrees. So those are the three things we know. Well, it's actually quite easy to find time with these things. We can find the time to go up by taking the final velocity minus the initial velocity and dividing by g. So in this case, Vf is 0, so we have negative Vy, which is Vi, divided by g. That's going to tell me how long it takes for this object to get to the top of its motion. So to get t air, all we would have to do is take 2 times negative Vy over g. So now it just comes down to plugging things in and actually solving for everything. So Vx is 64.5 meters per second times the cosine of 32.5 degrees. So Vx equals 54.4 meters per second. That's our first step. Then we need to solve for Vy. So Vy is 64.5 meters per second times the sine of 32.5 degrees. So Vy equals 34.7 meters per second. So we have Vx, we have Vy, noting that Vx is greater than Vy, which makes sense because our angle is less than 45 degrees, where the two should be equal. Instead, the angle is more horizontal, so the horizontal velocity should be more. So now to get t air, all we're going to have to do is do negative Vy, so negative 34.7 meters per second over negative 10 meters per second squared, and multiply that whole thing by 2. We do that, we get 6.98 seconds that the arrow is going to spend in the air. From there, just one more step to find dx, and go back to our equation up there, Vx times t air, well that's 54.4 meters per second times 6.98 seconds, and that equals 380 with the decimal point, take the significant figures right, meters. So those are the steps when bringing out something that's traveling at an angle. When you know the given angle and you know the velocity of the object at that angle.